Hello everybody, it's Mr. Joseph, and today we're going to verify trigonometric expressions. So, first thing I would do is make sure that you know all your identities, your reciprocal identities, your quotient identities, and your Pythagorean identities. I think having that in front of you is really important, and hopefully at this point you're starting to remember them. So I'm going to highlight in every problem what side I'm going to start on. So for this first problem, I'm going to start on the left side. So what I notice is that I have everything in terms of sine, and everything to the right is in terms of cosine. So what can I do here? Well, I see that they both have two signs in common. So what I'm going to do is I'm going to factor out a sine squared. And when I do that, sine squared times what gives me sine squared? 1. Sine squared times what gives me negative sine fourth? Sine squared. And a really nice part about this is this part now, which I'm going to highlight, this is part of an identity. And by that, what I mean is I'm going to go on just go down here for a moment. Well, I'll just do it down here. So if you recall, sine squared theta plus cosine squared theta equals 1. If you solve this for cosine, you will see that cosine squared theta is equivalent to 1 minus sine squared theta. So what I'm going to do here is for this part, I'm going to replace it with cosine squared. And now for sine squared, which I'm going to highlight over here, I still have an issue with this. I really do not want a sine squared. I really do not want it to multiply. Let me just bring it down. I don't want these terms to multiply anymore. So I have to think of what I can do to this term in order to make it a subtraction problem. So what I'm going to do is I'm going to go back to this Pythagorean identity that I have at the bottom, and I'm going to solve it for sine. So if I get sine by itself, this is 1 minus cosine squared of theta. So I'm going to go here, and I'm going to write 1 minus cosine squared of theta. And then I still have my other cosine squared of theta. I hope you're able to appreciate how we manipulated the Pythagorean identity sine squared plus cosine squared equals 1 in order to get us closer to our goal. So now that we have this, we can just take cosine squared and multiply it to each part. And if I do 1 times cosine squared, that's cosine squared. And if I do cosine squared times cosine squared, that's cosine to the 4th. Also, I hope you noticed that through that process, I actually changed it to theta instead of keeping it as alpha. And here, we were able to prove that they were equal. Once again, when I first started this problem, I just noticed that they both had sine squared, so I took it out, and look what happened. On 24, we're going to talk about something called conjugates. There is more than one way to solve 24, and I can show you both ways, but I want to introduce you to a method that I think will be helpful for you. So up to our math career, we probably haven't had to use conjugates a lot, and a conjugate is just when you multiply the bottom term by the opposite sign. So I hope you notice that instead of writing 1 minus cosine theta, I'm going to multiply it by the conjugate, which is 1 plus cosine theta. And I'm also going to do the same thing to the top. And you're probably wondering, like, why would you want to do this? Well, by doing this, I'm able to multiply the two bottom terms in order to get something squared. Because we know when we can get something squared, then we can start getting some identities that we like. So the reason why you're able to do this is technically just the number 1. Because whenever you multiply by something on the top and bottom, and the numbers are the same, that is equivalent to the number 1. Even though we're not going to use 1, I'm just showing you that you're allowed to do that because you're technically multiplying by 1. So what you're going to do here is you're going to multiply the numerator by the numerator and the denominator by the denominator. So on the top, I can put my arrows. We're going to get secant of theta plus secant of theta cosine of theta minus 1 minus cosine of theta over. We're going to multiply the bottom as well. We're going to get 1 plus cosine of theta minus cosine of theta minus cosine squared theta. So by doing this, we're going to see that this goes away. This part right here is just 1 over cosine of theta times cosine of theta, which is just 1. So that part becomes 1. 1 minus 1 goes away. And now we have secant of theta minus cosine of theta over 1 minus cosine squared theta. So once again, our goal is to get secant of theta, and you're probably thinking, seems like we're far away from this. But I have faith. I think we're getting closer. So what do we do now? We have some options. We can either subtract secant theta minus cosine theta and rewrite secant theta as 1 over cosine. Or we could change 1 minus cosine squared theta to sine squared theta. But I think I want to subtract what's on top, because if I make that sine squared theta on the bottom, then cosine divided by sine is going to give us cotangent, and I really don't want that right now. So what we're going to do, I'm going to erase everything on the top for a second. Sorry about that. And we're going to write, for secant, we're going to write 1 over cosine minus cosine. I'm going to multiply this by cosine in order to make it the same denominator. And when you're subtracting fractions, do you notice that both of these are the same? So you copy that once. And then on top, I got 1 minus cosine squared. So all I've done here is this statement right here. This is equivalent to that. So what I'm going to do now is I'm going to write 1 minus cosine squared theta over cosine squared theta divided by 1 minus cosine squared theta. Once again, this yellow part, this was equivalent to this part, and we got that from doing this math up here. So now that I have this, I'm going to put this over 1. I'm going to write 1 minus cosine squared theta over cosine theta times 1 over 1 minus cosine squared theta. Do we see that both of these are the same? You get 1 cosine of theta, and then you get secant theta. So once again, the conjugate was something useful there that helped me rewrite something that appeared difficult and bleak. Is that the only way for this problem? Nope. You could have gone to the beginning. You could have changed this to 1 over cosine, subtracted by 1, make common denominators, and do all that stuff. And you probably would get to the same answer. But by doing the conjugate, it also led me to this route, which I thought turned out pretty nicely. And you're not always going to see it right away. Sometimes you have to try it. I'm making a video, so I'm not going to show you all the trial and errors that it took me to get to that point. But the more practice you do, the better you're going to get. So let's go to the next one. So this next one is interesting. I see that I have cosine times cotangent on the top. So if I wanted to, I could just go ahead and multiply these. So let's go ahead and do it. Once again, that's what it looks like. So I'm just going to do it. So that cosine of theta times cosine of theta over sine of theta. So that is cosine squared theta over sine of theta. So I got that. And so now I have cosine squared of theta divided by sine of theta divided by 1 minus sine of theta. And all that is subtracting 1. So I'm going to deal with this part first, which is just this, everybody. Instead of dividing up and down, I write it side to side. Sometimes I feel like I get a better visual doing that. So now I have cosine squared theta over sine theta times 1 over 1 minus sine of theta. And once again, all of this is being subtracted by 1. The goal here is to eventually get cosecant, and cosecant is 1 over cosine. So it would be nice somehow if I'm able to get rid of these signs. So what I'm going to try to do here is I know that, once again, this cosine squared theta is equivalent to 1 minus sine squared theta. And now I also know that this looks like a factoring problem. So this is 1 minus sine of theta, 1 plus sine of theta. It looks like a difference of squares, so you should always try that out. And you see now that I'm able to cross out this and this. And let me move this out of the way, everybody. So this is pretty cool, and I'm about to show you. I can just pick it up and just drag it. So going back to this problem, I now have what left? I have 1 plus sine of theta over theta minus 1. And once again, our goal is to get cosecant. So I see this right now, and something beautiful is about to happen. This right here. Whenever you're adding two terms in the numerator and you're dividing it by a denominator, you can always split it up as 1 over sine of theta plus sine of theta over sine of theta. And then we still have the minus 1. You're probably thinking, why would you do that? Like, why? How do you know to do that? Well, I just noticed that if I do sine divided by sine, that I'm going to get a 1. And if I can get a 1 here, then this one and this one could subtract. And I have this 1 over sine, which I know is cosecant. Knowing that was my end game over here, I just thought to do that. And I hope you see here, you're going to get cosecant of theta plus 1 minus 1. This will go away, and you just get cosecant of theta, and it just works out so perfectly. So here, thinking to factor definitely helped because I knew I could get rid of that as well. So if you're also wondering there, why did I think to factor? Well, I knew 1 minus sine theta was in my denominator. So if I can somehow get that in the numerator, I could divide it out. All right, let's keep rolling. I'm going to erase this and bring that other one up there. y'all know I be taking up way too much space. Move it right back up. And let's do another one. All right, so when I see this problem, I can definitely put this over 1. There's a couple ways we can approach this. The right side, which is what we want to get eventually, looks complicated. So I don't think it would be a bad idea to go ahead and multiply this by 1 minus tangent of x, 1 minus tangent of x. The problem already looks complicated, so I think by doing this, we might get some information. Also, don't forget, when you're subtracting fractions, copy your denominator once, put all your terms in the numerator on top, and now we will evaluate what's on top. So now I'm going to take cosine and multiply it by both terms beside it. So I'm going to get cosine of x minus cosine of x tangent of x minus cosine of x over 1 minus tangent of x. Man, we already have nice things happening. The cosine and cosine are going to go away. And I have this awkward negative cosine x times tangent of x. So if I was going to do this, negative cosine of x times sine of x over cosine of x. The cosine of x are going to divide out. Then you have negative 1 times sine, which just leaves us with a negative sine over 1 minus tangent of x. Which, when I look up, I'm thinking, it's not quite what I wanted. But no stress. No stress at all. Because what we're going to do now is we're going to write this as negative sine of x divided by 1 minus sine of x over cosine of x. Once again, we're going to have to do some work here in the denominator, which is okay because we already knew this one was messy to begin with. So this is 1 over 1. We're going to multiply this by cosine, multiply this by cosine, and we're going to get negative sine of x divided by cosine of x minus sine of x over cosine of x. And now, do we see that? Does everybody see this? This is looking close to this. So what we're going to do now, let's go ahead and move this one. I'm totally failing at this moving part. What is going on? Okay, sorry. Let me move this bottom question again, everybody. Sorry about that. Keep dragging that down out of the way. All right, here we are. I have negative sine of x times cosine of x over cosine of x minus sine of x. Remember, when we're dividing fractions, you have to multiply by the reciprocal. Does everybody notice that we almost got our answer? We got sine of x times cosine of x over cosine of x minus sine of x. But the issue is this top part is positive and sine is positive and cosine is negative, but it seems like I have it the other way around. So all we're going to do is on the bottom, we're going to factor out a negative 1. So just watch this. So I'm going to take a negative 1 out on the bottom. And this is going to become negative cosine of x. And this is going to become sine of x. And then on the top, I have negative 1 times sine of x times cosine of x. The negative 1s will divide. And if I want to write this a little cleaner, I'm going to have sine of x times cosine of x over sine of x minus cosine of x. which is what we wanted up here to begin with. So we went on a journey here. We knew this one was going to be messy. We knew that we're going to have to simplify and have faith in the process that at some point we would get to where we wanted. And voila. All right, we got one last one. I know we're loving this, but at some point we all got to go. So we got this last one. We want this to equal this. Once again, an interesting observation is the fact that everything on the right side has cosine. So this first step is probably a little challenging, to be honest, because here we can't do anything with sine to the fourth. So what we're going to do is we're going to do sine squared times sine squared. And we're going to keep the cosine to the fourth x. If you're thinking why I want to keep it, well, I know I have a cosine to the fourth x right here, and I have one of them right here. So I'm thinking, from this part over here, could I make another one? Because I'm going to need two here. So what I'm seeing is this is 1 minus cosine squared of x, and this is also 1 minus cosine squared of x. And the reason why I'm doing this is because I know I need a lot of cosine squareds and to the fourths, and I know if I use the Pythagorean identity here, that this helps create that. And now all I'm going to do is I'm going to distribute. Now I'm going to get 1 minus cosine squared of x minus cosine squared of x plus cosine to the fourth of x plus cosine to the fourth of x. Sorry if I did that a little too quick. 1 times 1 is 1. 1 times negative cosine squared of x is just negative cosine squared of x. And then on the bottom, that repeats right here. And then negative cosine squared times negative cosine squared is positive cosine to the fourth of x. So here I see like terms. I'm going to add those. I'm going to get 2. And I think we have 2 more like terms. So if I have negative cosine squared, so think about it as having negative 1 cosine squared of x, and I'm subtracting a negative 1 cosine squared of x. That means a negative 1 and a negative 1 makes negative 2 cosine squared of x. And then we just have the one in the front, which matches. Final words to everybody is please don't give up. You have to keep practicing. You have to keep seeing examples, and you have to take notes. Once you use a move like the conjugate, which I taught you later, that's something that you have in your toolbox. For this question 62, noticing that I don't like sine to the fourth, that's not one of my identities, breaking it up to sine squared, and thinking about how can I take sine squared and make it cosines, because my right side is all cosines, help me do this problem. Have fun and good luck.